All right, ladies and gentlemen, your last lesson on scatter plots. This lesson is to help you figure out how we can use these trend lines, to be able to solve different problems that we get asked about when we look at a scatter plot. So this graph is all about members of a gym, and they were asked to keep track of how many minutes they worked out, as well as how many calories they burned. So you can see that your time is on the x-axis, the calories are on the y-axis, and you see a lot of your points are grouped together so that this trend line has been drawn, which goes through most of the points. Of course, you have a couple on either side of the line. You have this little guy down here, but overall, this trend line is a very good trend line because it goes with the data that was collected. So, as usual, we're going to write an equation for that trend line, which means we need our b value. It looks to me like we have a 0 y-intercept. And we need a slope, so if I find another good point, it looks like this point is a good one. And when I draw my slope triangle, I do have up 3 over 2 as far as the boxes are concerned. But remember, guys, your scale might represent something other than just 3 plain calories. In this case, 3 boxes actually represents 300 calories. And then 2 boxes this way actually represents 20 minutes. So if we use those numbers, 300 calories over 20 minutes, pretty sure that reduces to 15. So if you can reduce your fraction, you'll have a much simpler equation to write. And then remember, if your y-intercept is a 0, we don't need to include the plus 0 after that. We have a pretty simple equation. Y equals 15 times x. So guys, when you have an equation, you want to make sure you remember, what does the x represent in the equation? Well, that's easy. You just go back to your graph. This is your x-axis, and our x-axis was all about how long they were working out. So it's the time in minutes they worked out. And while we're here, we're going to make sure we understand in the equation, what does the y value represent in this particular situation. So if we found our x-axis, that means this is our y-axis. The y-axis is the amount of calories that were burned. The amount of calories burned. Okay, so knowing what the x and y stand for, we can actually talk about this equation a little bit. This equation is going to help us calculate y, the amount of calories burned, equals 15 times the amount of time they worked out. So if we can keep that relationship straight in our head, this equation can be very helpful when we have other questions to answer. So guys, these two go together based on this graph. These questions are still questions about the graph. So if we look at how many calories you'd expect someone to burn if they spent 120 minutes, well guys, 120 isn't even on your chart, and that's because I wanted to force you to use this equation. This equation predicts for us what's going to happen next. So we're going to start with the equation, y equals 15x, and you're going to remind yourself that, hey, I need to find the amount of calories burned, so that means I'm going to be solving for the y equals, and I'm going to take 15 times the amount of minutes. Remember we said x is the amount of minutes they worked out? So if I know x is 120, I'm going to multiply 15 times 120, and I'm pretty sure that comes out to be 1800. So guys, make sure you label your answer. We are finding how many calories were burned by somebody who was working out for that amount of time. So we need to say it's 1800 calories. Now this one's a little different. This one says if somebody burned 1750 calories, 1,750 calories, we need to find out how many minutes they spent at the gym. So the good news is we can still take our formula, but instead of plugging in the number of minutes over here for x, we're going to plug in the amount of calories since that's the value we know. And then we're going to solve for x. So remember what to do. If you have a 14 attached to x, or excuse me, a 15, you're going to divide by 15 on both sides, and you're going to come out with the amount of minutes it would take. So 1750 divided by 15, looks like I get a repeating decimal, but that's okay because you guys know how to deal with repeating decimals. All these 6's eventually the calculator rounds it up. So you're going to say it's 116.6 repeating, and this is minutes. that it would take them to burn that much calories. Now down here they want us to describe what the slope actually represents in the trend line. So if you come back here again, we can use our labels. The rise was the amount of calories burned. The run was how many minutes it took. So basically your slope is how many calories were burned per minute. If we reduced our fraction down, which I think we did, didn't we get 15? So that means it's 15 calories per minute. Now, last question for this particular graph is, what is the y-intercept of the trend line equation and what does it represent? So guys, we already found the y-intercept to be a 0. And what that means is we have 0 calories burned if there is 0 minutes working out. So that's what we'll say. 0 calories burned for 0 minutes working out. And if we wanted to be extra specific on this one, we could have given that the 15. 15 calories were burned for every minute of exercise. Now, what you guys are going to do, it looks like my note sheet got printed upside down again. Sorry about that. You have a practice problem over here that you're going to use the graph and the trend line to answer questions about. And then you've got one over here as well. So pause the video, try those 2 examples. When you're done, hit play and check your work. Okay, it's time to see how you did. This question really is important that you read the information in the word problem up here. Given the first point, 45% of the U.S. population smokes cigarettes since the year 1960, that's how I know this point is a 45, and that's how I know I can use it over here for my y-intercept. Now, besides using that point, I decided to go all the way down here to use that point on my trend line because that seemed to be the only point that was really perfectly on the grid. So guys, this is a drop in, I think, let's see, 5, 10 more, and 10 more. So that's a drop of 25 over 40. And if you reduce your fraction 25 over 40, it comes down to negative 5/8. So that's how I got my equation. Y equals negative 5/8 x plus 45. And then this question goes on to ask you, hey, what does the x actually represent? This, remember, is your x-axis, so that means years since 1960. This is your y-axis, so that means the U.S., or the percentage of the U.S. population who actually smoke. So some of the information you can get from the chart, some of the information, remember, you have to get from the word problem. Now the last thing that's very important that you understand is how to interpret the slope in context of the situation. If we drop 25% over 40 years, that's one thing you could write. Or if you use the reduced version of the fraction, it means you're dropping 5% over the course of just 8 years. Okay, so definitely make sure that you have the percentage over the years when you're talking about slope, because slope is always change in y over change in x. So with your last question, Lily is training for a 10K race. For some of her training runs, she ended up charting her time against her distance when she was running. So you can see the points are kind of all over the place, but there's a trend line that goes right through the middle. So we can rely on this trend line to answer some questions for us. One question is, obviously, if she didn't run, she didn't have a time. So that's why your y-intercept is 0. It looked to me like this is a good point to use. So when I drew my slope triangle, I showed a rise of 10 minutes over just one distance. If we paid attention to the labels, I know it's 2 boxes, but we have to look at our label for this. So it's really a rise of 10 minutes over 1 mile. So that means she ran a 10-minute mile. And that means when you put your equation together, you can simply just have it nice and short, y equals 10x. X, remember, is the distance that you're running. Y is the time that it took to run that distance. Okay, so putting those pieces of information together, hopefully you can make sense of the equation. The y, the time it takes her to run, is 10 minutes per mile. All right, so down here, again, this is what they wanted you to do, is just to interpret that slope. So again, it's minutes per mile that we got for our slope, 10 minutes per mile. And down here, we have to be able to interpret or predict what would happen if she was to run her full 10K race. Now, a 5K race is 3.1 miles, so that means a 10K race is 6.2 miles. And that's important because remember how your units are in miles? You really can't use this formula with a kilometer race. So we converted it. We've got our y equals 10x. Remember the X stands for the amount of distance she ran, so that's why I put my 6.2 in here. I've got to multiply by 10, and I do get 62. So again, just make sure you label your answer. How long will it take? It'll take her 62 minutes to run this race. So guys, you now have a nice little foldable note sheet that's going to go in your notebook. And I believe 112 for this side and 111 for this side. And then your title will be right here, Solving Problems with Trend Lines.